Now, in this question is asking 0.1 molar aqueous solution of alpha chloroacetic acid has Ka value 1.6 into 10 to the power minus 3. What is the value of Van 't Hoff factor? So, value of Ka is given to us, volume of concentration of is given to us, and we have to find out the Van 't Hoff factor. So, let us move on to the solution. Now, we have alpha chloroacetic acid. The formula is Cl CH2 COOH, and when it will react with water, it will give us CH2 Cl COO minus plus hydronium ion S3O positive, right. Now, the initial concentration of alpha chloroacetic acid is 0.01 molar, and since the reaction has not been started, it will be 0 and 0. Final concentration will be 0.01 minus 0.01 alpha, 0.01 alpha and 0.01 alpha, C minus C alpha and C alpha, the same thing we are doing here. Now, the value of Ka will be equal to 0.01 alpha multiplied by 0.01 alpha whole divided by 0.01 1 minus alpha, right. Now, we know the value of Ka, and that is equal to 1.6 into 10 to the power minus 3. So, we can directly put here 1.6 into 10 to the power minus 3, and after solving the quadratic equation, we will get alpha is equal to 0.33, right. Now, this is the case of dissociation. So, alpha is equal to I minus 1 upon m minus 1, right. Alpha, the value we know, that is equal to 0.33, and Van 't Hoff factor we have to find out, and chloroacetic acid will dissociate into two parts, therefore, it will be 2 minus 1. So, from here we can find the Van 't Hoff factor I is equal to 1.33, right. And what he is asking? He is asking what is the value of the Van 't Hoff factor. So, 1.33, the third option is the correct option, and that is our answer, right. Let us move on to the next question. Now, in this question is asking the pH of 10 to the power minus 4 molar aqueous monobasic weak acid is 5, that is pH is given to us. What will be the elevation in the boiling point in degree Celsius of the solution? Given Kb of water is 0.52 Kelvin per molal, and assuming that molality is equal to molarity. So, let us move to the solution. Now, let us consider the acid is Ha and it is reacting with water. It will give us A minus and H3O positive, definitely, right. Now, the initial concentration, it is given to us, that is 10 to the power minus 4 molar. So, we will write 10 to the power minus 4. This is 0, this is 0. Now, the final concentration. Final concentration, that will be 10 to the power minus 4, 1 minus alpha, and it will be 10 to the power minus 4 alpha and 10 to the power minus 4 alpha. Now, it is clear from here that 10 to the power minus 4 alpha will be equal to the hydronium ion concentration, right, and they are equal, and pH is also given to us. So, now it is given that pH is equal to 5, right, means the H plus ion concentration or the hydronium ion concentration, that is equal to 10 to the power minus 5, and it will be equal to 10 to the power minus 4 alpha, right, and the value of alpha, if we find from here, that will be 0.1. Now, it is weak acid and it is dissociating, that is why we will write alpha is equal to I minus 1 upon M minus 1. It is monobasic acid, that is why it will dissociate into two parts. Alpha is 0.1, we know that, I we have to find out, and M is equal to 2 minus 1, and when we will find the value of I from here, it will be 1.1, right. Now, what is asking? He is asking the elevation and the boiling point. So, we have to just find out the value of delta TB. Now, delta TB is equal to I Kb into M, right. Now, value of I we know, that is 1.1, the value of Kb is given to us, that is 0.52 multiplied by the molality. Now, what is saying that consider molality is equal to molarity. So, we can take 10 to the power minus 4, and when we will solve it, we will get 5.72 into 10 to the power minus 5. So, let us check which is the correct option. Yeah, 5.72 10 to the minus 5, this is, answer is option number 1, right. Let us solve the next question. Now, in this question is asking, in a hypothetical solid, A atoms form CCP lattice with C atoms occupying all the tetrahedral voids and B atoms occupying all the octahedral voids. If the plane is cut as shown in the figure below, now this is a figure given to us, which of the following is the correct cross section of the above plane? So, the options given to us are these 4 options, right. Now, first we have to know what is the position of octahedral and tetrahedral voids, then we will be able to solve this. Now, this plane will definitely pass through the atoms which are present at the corner. At the middle of this cube, there will be octahedral void, and if we draw a body diagonal, there will be tetrahedral void, and here also there will be a tetrahedral void, and again there will be an atom at corner. So, this one is tetrahedral void and this is octahedral void, means when this plane will pass through this solid, or when plane will pass through this unit cell, it will pass through the octahedral void also and tetrahedral void also, right. Therefore, you can see here B is present in the octahedral void, C is present in the tetrahedral void, and if we draw a same line here, so this line is passing through the tetrahedral voids and the octahedral void, that is B in the middle. So, this will be our answer. So, the answer is option number 3. Let us solve the next question.